I'm Vinny, and this is Learn Real Good.
I'm ready to learn.
Are you excited?
Yes, I just said I'm ready to learn.
Yeah, I like, when do you remember like first getting excited about learning, or like realizing that you like learning like maybe more than other people do? Because not everybody loves it.
My earliest memories.
Yeah?
As a very small child, I was always super curious, and I was blessed, given that it was the time before computers were in every home and the internet was in every home. My mom knew a lot of stuff. Mm-hmm. She knows a lot of facts. And so I'd be like, why is this? Why is that? Why? What? Why? All the time. And my mom had infinite patience to answer my questions and often could. And so it's just like a sponge for information. And then we'd go to school and be like, guess what about the world? I have learned.
Oh, yeah? You would share it with your classmates?
Yeah. I had a reputation for being like some freak. Not surprising to anyone who knows me, but like I just had a lot of information. People like, why do you know this?
Because your mom knew it.
Yes.
Interesting.
A conduit for my mom's
And so
knowledge.
now you're co-running a podcast with me all about learning more stuff.
I love learning.
I
I've
know, it's pretty
always
great.
loved it. I used to, like, for fun, I would stay up late, okay? When it was my bedtime,
yes.
I'd turn on my little light and I would read through like trivia facts.
Like a book of trivia facts?
I used to have like, I forget what they were called, but they came in this like bound, like rectangular bunch of facts, and they were by category.
Like a book?
No, it had a name. Damn. What were they called? Anyway, it was just like little trivia facts of different categories, and they would have the answers on the back.
Oh, right. Like
Yeah.
cards on
Oh, it's going to drive me
right,
crazy.
right.
It has a name.
Yeah.
I loved those. I would just drill through them until I knew all the
Interesting.
facts.
Wow.
Yeah.
Fascinating.
Yeah. How about you? When did you start getting spongy? Because you're spongy too.
Yeah, I like absorbing information. Yeah, probably as a kid too. Like really, like those are my earliest memories of just having my nose in a book. Just my parents like didn't have to pay for babysitters. They just dropped me at the library, and I was perfectly content to just wander and read and read
wow.
and read and read and read, and then they'd come and pick me back up.
Libraries are amazing. Isn't
Yes.
it crazy? You can just go and whatever you
I
want,
know.
take it.
It's amazing. Like I can't imagine trying to start libraries today.
Well, yeah, no doubt.
It'd be a very difficult idea to try to
Yeah.
get people to be like, what? Or at least governments and corporations and who knows what else. People would be into it.
Well, thank you for libraries out there.
Thank you, libraries.
Associated with libraries, working in libraries.
One of the great human inventions.
The invention of the library.
Should we tell people what this podcast is about?
Oh, right. Yes. So this is a science comedy podcast where we talk to each other. We share facts. That's
Yeah.
coming up next. And then we have an awesome guest who's going to talk about their grad research.
That's
And I'm excited for this one. This is a topic we don't know much about. I'm going to feel real dumb, but I am all about it.
Yeah, let's learn some stuff.
Absolutely. And we will.
Yeah, that's the whole point.
It is mandatory learning.
Mandatory
Well,
learning.
shall we start with a little taste, a
little
little
science
appetizer?
fact, a little science fact?
appetizer, yes.
Swap-
shall I
swappy
go
facts?
first?
Yeah, why don't you take a lead?
I'm excited about this one.
I love facts.
I actually saw this. My former PhD supervisor shared this research. And as soon as I saw it, I was like, I need to share this with Vinny. We're talking robots. Not just any robots, though. Robot fish. Now, before we talk
Whoa.
about the robots,
We're talking about the singing bass.
we're going... No, but it looks like one. I'm going to show you later. It's exactly what I thought of when I saw this. Inspired by Billy Bass. Have you ever heard of mosquitofish?
No, I've heard of mosquitoes and I've heard of fish.
Yeah. So if you were to guess what a mosquitofish is all about,
A
what
very
would you
tiny
say?
fish.
No. Well, I mean, it's not huge, but it's
It
not
eats
the
mosquitoes.
size of
It eats
mosquitoes.
mosquitoes.
Yes.
All right, great.
Okay, so this is an invasive species. Can you guess why it's been introduced?
To eat mosquitoes.
Yes. So
Okay.
mosquitoes, of course,
Yeah.
a huge plague to society, a
Yes.
vector for disease,
Terrible.
have been estimated to be responsible for half of all human deaths. I saw that statistic.
That's not good.
Mosquitoes may have killed half the people who ever lived.
I mean, I believe it.
Murderers.
Murderers, yeah. Let's return the favor.
So these mosquito fish have been
Yeah.
introduced very widely as a hopefully
Yes.
natural
Solution
way
to
of getting
mosquitoes.
right.
Perfect.
But guess what happens?
They've developed a taste for human flesh.
Not yet. But like most things, they eat other things. Fish are rarely very specific. They're mostly limited by the size of their mouth. Like
Right.
anything that fits in their mouth, pretty much.
Right.
So these mosquitofish have negative impacts on other things. They don't just eat. They're not just vacuums for
But
mosquitoes.
they're called mosquitofish. They shouldn't be allowed
Well,
to eat
that's
other
their
things.
nickname. That's not, yeah. So they will chew at the tails of other fish. And
Well, that's rude.
Very rude. They should be called rude fish.
Rude, very rude fish, in fact.
They chew at the tails of other fish and tadpoles, and that makes them open to infection and has had negative impacts on their populations.
Wow.
So mosquitofish, big, bad invasive species.
Man.
But they're hard to get rid of because there's many fish we want to protect.
Right.
Some fish are bad. How do you separate one fish from the other with a poison, right? It's very tricky. Usually if you want to...
We introduce a mosquitofish fish.
You know, these stories exist.
I know.
These case studies where you just keep...
Introducing
this
larger
is an arms
things.
race.
Just,
yeah.
Finally, we introduced tigers. I think there's a Saturday Night Live sketch about this.
Yeah. Anyway, well, what if we can use robots? So they
also have unintended consequences.
If they become sentient robots.
We didn't have any worries about the mosquito fish until they started causing problems.
Okay, well, these researchers have created their Billy Bass. It is a bass, actually. It is a robot mimic of a largemouth bass that not only looks like a largemouth bass, but can mimic their behavior.
Whoa.
Yes.
And their voice.
And their passports. And so what they've done, like in a controlled situation, they use magnets to control the swimming of these bass. So, I mean, how you would extend this to natural populations, I don't know at this point. But in any case, in experiments, they were able to show that just the presence of this predator was enough to keep the mosquitofish from being bad guys. So they would get, even with one sort of predation event, so they would have the robot sort of swim around, the mosquitofish would be so freaked out for weeks that would have negative impacts on their body weight.
Wow.
And therefore number of babies they would have. So they could limit the reproductive success of the
just
mosquitofish.
by introducing
and it doesn't have to be constant. Like they were able to show that this guy swims by, they freak out, they stop eating. They invest their energy into more powerful tails for evasion, and they're not spending their energy on reproduction.
It's like they're Freddy Krueger.
They're in their nightmares.
Or the Terminator maybe is a better analogy.
I like Freddy Krueger. I like thinking that the mosquitofish...
It's like dreaming.
Yeah, I mean,
Billy Bass!
I know very little about Freddy Krueger. It's something to do with dreams,
nightmares,
right?
Nightmares,
not dreams.
Yeah, more nightmare than dreams.
Pleasant.
He's so dreamy.
I like that striped sweater. Anyway, so that's
amazing.
It's pretty cool, right?
Just by introducing a robot fish, you can keep it down.
Potentially.
So we should have introduced robot mosquito fish. That would have really messed up those mosquitoes.
I don't know the mosquitoes necessarily have the brain capacity to...
Whoa.
I'm sorry mosquitoes, but I don't know that they feel fear.
I think if you kill half of all living humans who ever lived, I don't think you get a little big carte blanche to do whatever you want.
I mean, I agree.
Let's get rid of them.
Well, yes, mosquitoes are a scourge. They're not something you need in a food web. They're not a keystone species.
If there's a species that could go extinct, I definitely would pick mosquitoes.
Absolutely.
Yeah.
Its role is redundant, right?
Yeah.
There's all insects are sort of doing not so great. So
well, then we're on our way. Worth it.
We need them. Pollination.
All right.
Well, that's my fact.
That's pretty cool.
Not bad, right?
That's very cool.
Okay. Well, do you have a very cool fact?
I have a fact. Well, see, I think it's pretty neat. I think it's fascinating.
Full disclosure, prior to recording, Vinny admitted he wasn't super thrilled about this fact. So
I actually quite like it. I was just being silly.
Okay. Let's hear it.
So space.
The final frontier.
The final frontier. It's where people sometimes envision going. And there's lots of problems.
That's how I define space.
Yeah, space.
What
where
is
people
a
want to
place
go?
where people sometimes
I really hedged my bet on that too.
Yeah. I'm not thinking about going to space right now.
Yeah, you weren't even envisioning it.
Nope.
All right. So people do go to space, and it's important that they're taken care of. They don't immediately die when they're up there. So there's a lot of research that goes on to how to prolong and make sure people are taken care of when they're in space. And so one recent study showed that there's a problem in microgravity. It introduces errors in cell replication. And so that's a big problem. Like when you get errors in cell replication, it's basically cell aging, and you get the more errors that accumulate, the more likely you get all sorts of diseases like cancer and whatnot. And so to test this, they didn't bother going to space. They did it here on Earth. Because once you're in space, you get all sorts of solar radiation, and you're already getting a ton of cellular damage just by leaving the Earth's magnetic field, which is what you do when you go to space. So a lot of that radiation will knock out your DNA and cause a lot of errors. But even here on Earth, if there's microgravity, and so you can get like very low gravity, not zero gravity, but microgravity, by going up into a plane and doing what's called a parabolic dive. So for about 20 seconds, the plane just falls at the same rate as gravity. And so everything inside that plane is essentially in free fall. But inside the plane, you think you're in zero gravity. So you're just moving around and floating at the same rate as the plane. And so then it pulls up. But for those 20 seconds, you get free fall and experience functionally zero gravity. And so they ran a bunch of tests in those 20 seconds. Like they did a whole bunch of these, and they replicated some E. coli, and they compared DNA before and after, and the copies all had way more genetic errors than you would get in a non-microgravity situation.
Wow.
And so it's an actual danger, not just the space radiation, but also just being in a zero, low gravity, microgravity environment, your cells will make errors because it somehow uses gravity, just like everything else does.
That is really interesting. Wow. That's crazy.
Yeah, just microgravity. Who knew cellular copying, gravity has an effect on that?
Well, because, I mean, I know very little about this. I know CEGEP level material because that's what I teach. But there's an enzyme that basically reads a base in one strand of your DNA and adds the complementary base. So I wonder what part of that is affected by gravity.
I'd have to read the paper. I only read like the article, very small article summarizing.
There's no
the
way
paper.
to know.
Yeah. But I thought it was fascinating. Just even that finding was really cool.
Of course. It's not just that it's being mutated by a force. It's the errors that are occurring in the copying.
Yep.
Wow. Or it could be increased level of errors occurring or decreased level of repair, right?
It looked like increased errors occurring.
Well, increased errors being maintained, right? You can't know if that's a failure in the actual making.
I guess
I
don't think of cells being repaired after copies. Like, is there like some kind of copy check?
Yes.
Whoa.
It's called proofreading. So the enzyme that does the copying has the capability, if it makes an oopsie, say it's supposed to add an A and it adds a T, it can be like, oops, I just put the wrong letter, cut it out and put in the correct letter.
That really happens.
Yes, but then there's also other enzymes that can sort of scan your DNA, and if they see an error, cut it out and repair it.
Whoa.
Yeah.
That's really neat.
Absolutely. That's why in our intact DNA, we have 1 of 100,000 original errors. You fix most of them.
Unbelievable.
The more you know. Okay.
I think it's time for our guest.
I know it is. Well, you get to introduce our guest this time, Vinny.
I'm very excited about this.
Go for it.
Our guest today is Frederick Gietz, a PhD candidate at the University of Toronto, working virtually and living in Ottawa. His research focuses on natural language processing for aspectual verbs and the semantics and psycholinguistics theory behind it. In his spare time, he enjoys playing RPGs and the piano. He also loves drinking coffee and looking out the window. It's Frederick Gietz. Hey, Fred.
Hello. Thank you guys for having me. I'm super excited.
Thanks for being here.
Yeah.
Yes, welcome. We're excited.
Thanks so much for joining us.
I love the facts. I remember the same fan cards of trivia, and I also cannot remember what they are called.
Yeah.
Was it Brain something?
Brain something.
Quest?
Yes, it was Brain something.
Yeah.
Damn.
Brain
Brain
cards.
Quest.
Brain cards?
Damn it. Brain cards.
Brain flex. Something like that.
If you're out there, brain cards, please sponsor us.
Well, thanks for joining us, Fred. There's like 5 parts of your bio that I actually want to dig into. But yeah. All right. So let's start with like a high level description of what it is that you do.
Yeah, for sure. So at a very broad level, I do computational semantics, which means I'm trying to make computers better at understanding the actual meaning of words that they're processing. And you can kind of think of my research as like a fill in the blank test, where if you give a human speaker of English a sentence like, I finished a beer today, and you give them a sentence like, I finished a book today, the human has a pretty good sense that I finished a beer means something like drink I finished drinking a beer, and that I finished a book means something like read, I finished reading a book. And the way that a computer usually represents this is with only the meaning of finished as one thing.
Mm-hmm.
And so my work is about getting computers to recognize when finish means finish drinking or finish reading or writing or making or whatever it does from sentence to sentence. So that's it in a nutshell. That's what I do.
Wow.
That's
And so
cool.
I'm guessing that that's what an aspectual verb is.
Yes.
Like a verb that has a different meaning depending on the context.
Yeah. An aspectual verb is a verb that's about like the start or the end of something. So like start, finish, complete, begin.
Oh.
Yes.
Oh, so specifically those verbs.
It's very specific research that
Interesting.
draws on a very broad theory of meaning.
And why those verbs? Is it just because like that's a sort of size of packet of work that you can do, and then someone else is working on like jump and throw, and someone else like
Kind of.
Smell
Kind
or
of.
is there something
Sneeze.
particularly interest or meaningful and important about those verbs?
So it's a little of each.
Okay.
Every bit of work in computational linguistics is usually about this level of niche until you get to the level where
Wow.
you're like working in the Google lab, running models on the entire internet, churning out a general language model that everyone in the
Right.
field's going to use for the next 5 years or whatever. But yes, it is a very specific niche, and there are people who do work on kind of similar areas with similar theory behind them. So like there's some work on how on adjective plus noun combinations, where if you say
Holy.
this is a really difficult mountain, you mean probably a difficult mountain to climb. But
Right.
if you are a photographer and it's snowing out, you might say, oh, this is a super difficult mountain today, and you're meaning to take a picture of. So it's the same kind of deal where
Right.
the context modulates the event you're actually talking about.
And computers are bad at that.
And computers are pretty bad at that.
But you're working to fix it.
I'm doing my best. I'm doing my best.
Now, Frederick, when I try to picture what your day is like, okay, as someone who knows very little about how my computer works, I know there's zeros and ones, and then you lose me after that. Now, I picture like you're facing a computer and you sort of type in a sentence, and then the computer like responds to you with its guess as to what you mean. And if they get the wrong one, you like slap it or shock it. And then eventually, with, you know, suffering on the computer's end and enough
I hope this
iteration,
is. I don't want to be in any of your classes.
it's a computer. I like how they did in Ghostbusters, right? When Bill Murray is doing his research, or
Right.
something akin to that. How do you train a computer?
I would say you've got the idea
See?
of it right, and none of the specifics right. But you
like a
As opposed
computer.
things.
Like a computer.
you have the basic idea is I show a computer a sentence, I tell it to guess a verb.
Right.
And if it's right, I say, wow, good job. And if it's wrong, I say, we got to change something.
Wow.
You've basically got it right. The way that a lot of computational linguistics works is by representing each word as a vector. And if you have not brushed up on your linear algebra for a long time, basically you can think of it as each word has like a list of numbers associated with it. And the idea is that you train a model in such a way that the numbers that you're representing a word with encode meaningful relationships between the words. Because if you know something about vectors, you can actually do mathematical operations on them. You can add them, you can subtract them, you can get the average of them. And most importantly, you can compare their distances to one another. You can compare how similar one vector is to another. And so that means you probably have a good language model. If your vector for cat is kind of close to your vector for dog and kind of far away from your vector for table. And there's a whole battery of kind of standard tests that models get evaluated on for this kind of thing. Some of them are very fun. So it's like you want the vector for king minus the vector for male to equal the vector for royalty, and all these like
Whoa.
kind of abstract,
Whoa.
kind of logic analogy tests. And if you have a model that does pretty well on those, then you're happy with it. That's kind of the
You
way
must be really good at the board game code names. That's what I'm thinking.
I'm shockingly bad at board game code names.
Because you think like a computer, you're like, don't you know that king minus male is royalty, you moron?
Yeah, if the word is royalty, that's your clue. King minus male, and we're all like, what?
Yeah, I either go like super semantic featural, like picking out little bits of meaning, or I just wing it. I overcorrect, and I'm so wrong all the time.
Wow.
You know too much.
Yeah.
So how many verbs are you working with? So start, finish. What else is there? Is there like
Start,
1,000
finish, and begin,
or 5?
complete. In the experiments that I typically run, we are working with just this list of 5, just to limit the number of sentences we can draw out. There's something like a dozen or so verbs that kind of fit this bill, but we already have more data than we know what to do with for the most part. And if you look at just the sentences with these 5 verbs that I work with, start, end, finish, complete, and you, starting from there, already narrow it down to just the sentences where you have that verb with a subject and object and maybe some other fluff. And then you just narrow that down even further to ones where the direct object is a physical thing, because that's relevant in the psychological theory of all this. If you narrow just all of those, you still have about 5,000 sentences from a corpus of a couple million sentences. So like a lot of computational linguistics, I'm dealing with really big volumes. But then also, if you want to say something about all these verbs ever, 5,000 suddenly seems like very, very few, and I wish I had more. So yeah.
Wow. So is most of your day spent like, you've already plugged in all the sentences and now you're mostly like trying to pull out data from the big pile of data and synthesize?
What it's looked like for the past year or so is that we've pulled out actually an even smaller set of those 5,000 sentences. We've pulled out 300, and we've also done like human testing on these for a couple of things. What the day looks like is basically I'm doing some kind of new analysis on this little tiny data set of 300 sentences that we have that we're hoping extrapolates to all of these verb uses ever.
I'm trying to wrap my head around this, and you're taking these 300 sentences and basically building a vector map?
We take these 300 sentences, we literally treat them like a fill in the blank. So we take the sentence, I finished my dinner, we show the computer, I finished blank my dinner. And we tell the computer, imagine there's a word at this blank and try to guess what it is.
And it's got to guess eat.
It's got to guess eat. Yeah, it's got to guess.
Right. And then so you're going to take that, you're going to train it on this and then try to predict like how it reads the remaining set? Yeah.
So we take these 300 sentences and we split them in half into 150 and 150. 150 that we train on and 150 that we evaluate on.
And then, okay, because I'm going to be so hilariously wrong to entertain you, Frederick. My guess is at the end of this, your end game. Okay, you train your computer, which you've slapped a couple times. And then you take it to businesses and you say, I trained this computer to understand when to say finish correctly. Now he can train your computer if I put in this floppy disk. Like what's the application once you train a computer?
Did you say floppy disk?
Yeah, that's correct. Right. Into the greater computation world. I guess.
Yeah. This is a very good question.
See?
This is also, in my opinion, kind of a fundamental problem with many, many computational linguistics endeavors. Because you have exactly this case where you're evaluating a very specific type of performance on a very specific type of data set. And really, when it comes down to it, the big applications of these kind of predictive models are things like predictive text for your phone and like text to speech, predicting what the words should be in a sentence to get you the best sentence in the end. So when you zoom out to that kind of scale, what you're looking at is something behind which there have been probably hundreds of little data sets like mine training these models on very specific tasks to try to get better at capturing very specific aspects of meaning. Wow. But the real goal of that is that we'll be able to say something about the way that humans process meaning themselves when they use these sentences. The real goal is to be able to say, here's how I made my models do better. And so we have our own little guesses about how humans actually process these sentences.
Whoa, so is this what happens in our brain? Like, do we have our own little psycholinguistic map of meaning, and we're constantly, like, as little kids, evaluating and being corrected? I guess that's what's happening.
It's kind of what's happening. The really, I was going to say annoying, but also exciting part of my research is that this is not quite how humans deal with this in their brain. And so you've got a history of research on aspectual verbs that assumes humans see a sentence, humans treat it like a fill in the blank, humans process a verb that represents an event, bada boom, bada bing. And one of the big contributions that we have done with our work specifically is showing actually this way of thinking about it itself is not complete. So I know I just talked for like 10 minutes about how this is basically what I do, but basically what I do is say that that's basically what I do and then show how that's totally wrong and we need an even more complex model of language.
Well, so peel back the layer on that one. What is actually going on?
Yeah, okay. So we can do a little experiment with you two.
Oh my goodness, Katie's eyes just got 10 sizes bigger.
Please do.
So we're thinking of these as like fill in the blanks. And I'm going to give you a sentence with the aspectual verb complete, the verb complete in the sentence. And I want you to tell me the verb that sentence is actually about. So, you know, if I said I completed my beer and it was delicious, you tell me drink.
Right.
Got it.
Okay. So the first sentence is, let me run through.
Sure.
I have a battery of these examples in my head, and I have to make sure I'm gonna not smush two of them together accidentally. If I gave you a sentence like, the drag performer completed her superhero costume just before the show, what's happening in that sentence? Completed her superhero costume. What verb would you give to that?
Has sewn.
Vinny?
I would say like added a missing piece. Like found the last
more than
piece.
one word though, isn't
Yeah,
it?
That's okay.
true.
That's allowed.
Yeah.
That's cheating.
All right,
but yeah, we have sewn, we have added a piece. You have this sense of like creating and making, production kind of.
Yes.
But I can give you a second sentence. Which is very similar, and I want to hear what you think. If I say a sentence like, a pair of fake glasses completed my superhero costume for the Halloween party, what do you say the verb is going on there?
It's sort of, since we can use multiple words, it's sort of fulfilled a whole look.
Yeah, like the finishing touch.
Like the missing piece.
Yeah.
What you're probably noticing, I love elevated. I wish all of my participants brought that kind of energy to these. But what you probably
You haven't
noticed,
called us.
what you noticed is that second sentence is harder to think of a verb for.
Totally.
And all of the work we have in the past on this subject, Gietz dissertation 2022, here's hoping. All of the work we have only deals with the first kind of sentence, the ones that are pretty easy to think of a verb for. And so that's why we treat this task as pick the best verb, because we're assuming humans are going to read these, humans are going to have a verb in mind, bada boom, bada bing. And so, yeah, a big part of my research has been just laying the groundwork to prove you guys are missing a lot of examples, and you're not going to do a good job with these verbs if you don't actually broaden your examples.
So what percentage would you say, like, does the original idea cover? And then what part of it is like, how much are we missing?
Okay. Yes. So out of all the aspectual verbs, the original classic examples, easy to come up with a fill in the blank for, are only about 10 to 20% of all the uses.
Wow, that is a very small percentage. That is much smaller than I was expecting.
And it's so popular, I think, because two guys wrote about them in the 1990s as a formal semantics concept. And so their paper had like 6 examples in it, because it's not a computational work, it's a linguistic theorizing. And so all the work is kind of just use those examples, and all of the data sets in the past have been like, okay, we'll make examples kind of like those and it'll work great.
This is like a pretty big finding, Frederick.
And not at all computationally related.
So that's where the semantics and psycholinguistics come in, is that in order to improve the computational models, we've so far already had to get a better understanding of the psychology underneath these when speakers are reading them.
Whoa. So does this mean you had to like learn a whole other field? Like you're a computational linguist. Now you have to get into all this other theory.
The field of semantics.
I did it the other way around. I started in psycholinguistics. I started in semantics, tried psycholinguistics, and then settled on computational linguistics because I wanted to make money one day.
Yes, also useful.
Sorry, semanticists out there.
Yeah. all 12 of you.
Well, they're all listening to this.
They're all
They're our biggest fan base. Oh, wow. That's so cool.
That is very cool. Now, hang on. I have one more question here that's super relevant.
Vinny's brain's buzzing.
Are you haunted by the word start, finish, complete, begin? Like, you see that word and you're like, I can't see this word today.
Yeah. It's everywhere. And the really exciting thing for my research is that still to this day, I hear people use it. And if I'm thinking about it in this fill in the blank kind of way, they have a new verb in the blank that I've never heard before.
Wow.
In like a video game where there's these things called chunks that you try to get through, someone said they completed a chunk. And I was like, oh my God, I don't know what you would fill in the blank for this one, because
I finished a level.
Yeah, it's exactly like I finished a level. What did you do? Yeah, so they do haunt me. They definitely haunt me.
I really hope you have a shirt that just says start, begin, complete, finish.
One of those like
end.
Ampersand.
Yes, exactly. All in Helvetica.
Yeah. Even the 12 semanticists should make that.
It'll sell 11 copies.
Yeah.
I have a question. You may not have an answer to this. We can always cut it. But Frederick, can you remember offhand like a really hilarious computer error when it's trying to sort of understand a sentence, where it's just like way off? Or
oh my goodness, that's a really good question.
Yeah, do you have a file with all your computer bloopers?
I do. I do have a file with all the results that have come up. I don't have a really hilarious one.
Damn.
That's okay.
Yeah, I'm so
need a
sorry.
t-shirt for that too. That's okay.
Yeah. I'm sure there
there
is one out there, but I don't have it on the top of my head.
If you think of it later, you can always email it. We can add it.
I feel like that's a great Twitter account I would definitely follow.
I do have
Twitter bot.
Computational linguistics errors.
And unexpectedly, I guess just unexpected example. So I'm extracting all my examples from a corpus. So it's basically just a big, massive set of text files to search through, and they're from like TV transcripts and novels and academic papers and a whole bunch of stuff. So once in a while you do pull out an example that's like, where did this come from?
Because you just get the snippet out of context.
Yeah,
right?
I had one that was like some wild fantasy novel, and it was like the incantation completed the bond between the master and beast, and I was like, I don't know what I just walked into, but the corpus only has like this paragraph of context, so I will never know. I will never know.
That's unfair.
I
It
wanna-
needs to have the little anonymous, the little attribution at the bottom.
Yeah,
wanna-
I could do some digging, but I like the mystery. I like to not know.
No kidding.
That is cool. Well, Frederick, how did you get into this? Like, how did you get into semantics?
Yeah, what's
Like-
your academic journey like? Like,
Yeah.
you're like, you finish high school and you're like, you know what? I love words.
Yeah.
That is kind of how it started. I really wanted to do translation. I thought that was so cool. I really, really thought it was neat when people could translate live, like start live interpretation, basically. But when I was finishing high school, I did not speak any second language well enough to go down that path. So I tried out linguistics. The very cool thing about linguistics, they hook you early on, because early, like first, second year linguistics problem sets are basically all logic puzzles. They're basically all just little logic puzzles where you're trying to like reverse construct some phonological rule. And you're looking at like 20 words and you're like, okay, what's weird about these? How does the P sound turn into an F sound in this language or whatever? So it's very fun. It's a very fun thing to learn. And I've shown some of these like logic problem style problems to some computer science people, and they're really into them because they're cool and fun. So I got into linguistics early on. I got into formal linguistics, formal semantics originally, and did a honors project in my undergrad. But at the same time, I was doing a math minor. And my favorite part of that was the algebra. And it turns out that the two things you need to do computational linguistics research are
That's crazy, eh?
a linguistics theory background and a decent grasp of linear algebra for the vectors and stuff. So
Those seem so disparate. It's wild that those two interests.
There is a intersection of that Venn diagram.
Yeah, I don't think I would have known that at the beginning of my undergrad. I was just like, I like math, I like linguistics, and I like psychology. I did a minor in psychology as well. So those three pieces have followed me the whole way.
Yeah, you're living the dream now.
Yeah, you are really right at the intersection.
Yeah, so it's definitely put together all the pieces from my academic career, I guess.
Now, tell me more about RPGs. Now, I'm going into the personal. Like, do you still play?
Oh, I love to.
Games?
Yeah, I have several on the go right now.
Oh, tell me all about it.
Okay, I really love to use this. This is my hottest take, but I'll die on this hill. I really love an RPG system called GURPS, which stands for Generic Universal Role-Playing System. And many RPGers loathe GURPS because the manual is 600 pages long.
Yes, it is.
But it's such a delight. It lets you do any story. It lets you mix genres super well. And I love that there's a rule for absolutely anything you can come up with.
It is so old too.
It is really old. Yeah,
it's like 35. It's like probably the only thing older than it is pretty much D&D.
Yeah. It's on 4th edition. It's ancient.
Yeah, it's amazing.
Does it? So as a non-GURPS aficionado, is it? I don't know very little about D&D as well, but I actually very recently joined a D&D group, so need to learn about it. Is it? Thank you. Is it similar? Like there's you create a character.
Yeah, it's the same basic idea. You're making a character. The GM is describing your situation, and then you're rolling dice, and your character sheet tells you, oh, your climbing level is 14. Your roll is good enough. Cool, you did it.
Right.
The reason I love GURPS is that there's a whole system for giving your characters disadvantages, and those are often personality disadvantages and story quirks. So you can play like a super chummy character who literally can't be alone, or they take a penalty on their dexterity and IQ checks.
Wow.
And that's part of your character sheet. That's baked right into it.
I
And
love it.
I just think that's so fun, and it makes everything very like narrative and character focused. Where I find
I
D&D usually gets like combat focused first and foremost.
Right.
And GURPS, it's hard to do that because combat is brutal, and if you get into a fight, it takes you 4 hours in real time. So no one wants it to be combat focused.
So it's basically an improv game, it sounds like.
That's how I like to do it. Yeah.
Yeah.
GURPS done well is like an improv game. GURPS done poorly is math homework.
That's a great way to put it. Now, are there other systems that you're playing at the same time, or is it mostly just several GURPS campaigns?
I have multiple GURPS campaigns. There's a couple other systems that I really like that I always come back to. There's a one-shot called 10 Candles, which is just the coolest ever. Every time you fail a roll, you extinguish a candle, and for the last candle, when it extinguishes, you die. So it's like a horror with a super dramatic irony kind of thing, where you guys playing it, sitting around this spooky dark table, know that everyone's going to die in the end. And
right, because everyone gets the 10 candles.
Everyone gets the 10 candle. Yeah.
Oh,
That's
cool.
great. And the piano, how does that fit into your life?
Yeah,
it's all fascinating.
Piano is, I just made the bio nice and juicy. Yeah, I took lessons when I was young. I didn't touch a keyboard for a couple of years in my undergrad, and then I just started getting back into it bit by bit and trying to relearn what I knew and get better and be able to like improvise and get a little bit of a repertoire going, be able to play like some pop and jazz and all that kind of good stuff. So do you relate it to like your math? Do you see the notes and chords and keys as a system? I often try to. A very fun game that I learned on the piano, I think I got this from a musician named Jacob Collier, and he has this like music theory learning thing where it's just like, play some notes, just play like 7 notes and see if you can work out a way that you can resolve that into a nice harmonious chord.
Wow.
And I do think that kind of thing is super fun. But mostly I just play to have fun, play to sing.
Wow. So what's next for Frederick once you finish this seemingly very important research? What's next? I'm convinced.
Seemingly.
It seems pretty groundbreaking to me, but I'm not a professional in this.
Seemingly very important is how I would describe it.
Don't put that one in your. That's like illegal.
Did you finish?
Frederick Gietz does seemingly very important research.
Yeah, potentially okay research.
It seemingly is reflecting on Katie's knowledge of it rather than how it actually.
I was just hedging my bets.
Yeah, I like it though.
Okay, once you finish the most important PhD thesis of all time.
Now we're overselling. We're way overselling.
No, too far. Computer.
Once you finish your PhD,
there we go.
What's next?
Yeah.
Do you have any ideas?
I have some ideas. Most of them are not to do any research for a little while. I'm
burnt out.
Quite burnt out. I'm well into my 7th year at this point.
Yeah.
And that's now, I've tipped over the average completion time for a PhD. So it's dragging on. I probably, in all honesty, would just want to work for a couple of years, take a break, take some time. Maybe the siren song of aspectual verbs will draw me back in. I'm definitely leaving the dissertation with a couple unanswered questions. So who knows if it'll rope me back in? But my plan is to never think about it again if I can help myself.
Right.
I know that feeling well.
Yeah.
It's interesting that you mentioned like the 7 years and it's above the average. Like I feel like there is a pressure to complete things like in like the quote unquote expected time frame.
Yeah, it's really, in my experience, the expected time frame has just been so demoralizing because at U of T, the way they do it right now is you have your time in the funded cohort, which is usually 4, sometimes 5 years. And then if you want to go on further than that, because the stated program length is 4 years, you have to submit your extension request to the School of Graduate Studies. And the hope that kills you is that to submit an extension request that's likely to be approved, you have to explain how your dissertation is achievable in 1 year. And so around extension time, every grad student is putting on this little play by text where they write the fantasy version of their dissertation that's super easy to finish. And now I've done that 3 times.
Yeah, and those things take time. It's like, if you want me to finish, maybe don't make me do this song and dance again.
I have many choice words for many different aspects of the U of T grad program, but I think it's part of a broader...
one or two spectual verbs for them.
Yeah.
But it's not just U of T.
No,
like that.
It's
the whole system.
Academic culture for sure.
Yeah.
Yeah, it's tough. Like they don't fund for the length of the project, right? They have these rote guaranteed funding times, and then after that, you're sort of thrown to the wolves to figure out your own funding or get jobs outside, and it's
finish it on your own.
Real tough.
Yeah. The other thing that's been a frustration in my case is that the actual work on the actual dissertation has in fact been about 4 years, but all of the qualifying papers and coursework and stuff already came with its own set of delays that on its own, the dissertation would be enough to fill that 4-year block. And I think that's the case for a lot of people as well, where just all of the grad school things you have to do end up taking out their own chunks of the time.
And then there's the people who just can't do it because of COVID.
Yeah.
And then how does that factor in?
What a nightmare.
Like if you have to go into labs or work with groups of people to do your research, you're boned.
Yeah, this is where I'm super glad that most of my data collection right now is stuff I can do online, stuff I can do by crowdsourcing. So yeah, it's just if I had still been on psycholinguistics projects right now, that would be another year gone. So it's tough. It's not a good time. I'm gonna finish it, and I'm not gonna like it. I'm not gonna like it.
That is fair.
That probably is more common than you might expect.
Oh yeah.
People are just dragging themselves across the finish line.
Absolutely. Yeah. It's the cruelest marathon.
That's a good title for our research documentary.
The cruelest marathon.
Well, Frederick, you sound like a superstar. Your research sounds like...
This is awesome. This was
incredible.
Super fascinating. So.
It's way beyond our brains, but it was very interesting to listen to. And if ever you need a couple of ding-dongs to fill in some Mad Libs for you on spectral verbs, we are down to clown. Yeah. We're leaving it in. Okay. Well, thank you so much, Frederick. This was so fun.
Thank you. This was great. Thanks for being here.
Yeah, thank you guys for having me. This was a very fun reminder that research is chill and makes people smile and is fun to talk about.
It really does.
That's our job.
Thank you.
Bye.
Guys.
Good luck finishing up.
Thank you.
Bye.
Wow.
That was amazing.
Computers.
Yeah. Who knew one language was so complicated? I guess a lot of people do. 2, linguists generally. 2, getting computers to understand that sounds really difficult.
Where my mind exploded is the idea, first I was thinking we're teaching computers to understand language better for whatever programming purpose. Cool. But the idea that learning how computers learn, having that shed light and show the difference with how humans learn language.
We thought how humans learn language. Yeah,
but that's fascinating that you can make those links. This is how we teach this thing to do it. This is what we do. Here are the differences and finding the meaning in that. That's fascinating too.
Computers.
Humans.
We don't teach computers. They teach us.
Yeah, I guess.
Yeah. Well, that was a great episode.
Is that the moral of the story?
Yeah, that's the moral.
We learned so much. We learned about robot fish
and taking E. coli,
errors.
on airplanes,
microgravity,
and computer words
and language. Yeah, and what an spectral verb is.
That's a great word.
Yeah, fascinating. Well, I had fun, Vinny. Why don't we send our guests out on our socials?
If you're interested in following us on social media, check us out on Facebook, Instagram, or Twitter at LRG Pod. That's LRG Pod. And if you're a STEM grad student in Canada and you're interested in being a guest with us, just send us an email at learnrealgoodpodcast@gmail.com. That's learnrealgoodpodcast@gmail.com.
And if you're listening to this and you are a learner, a Learn Real Gooder, We would love if you could leave a review for us. We've had, I believe, last time I checked, 6 5-star reviews,
We're on our way up.
but only 1 text review. And thank you to that fan that left that 1 text review.
Yeah, no, reviews really do matter on like algorithms and visibility and how they get promoted in like the whole podcast system. So if you can take your time and you want to help us out in a non-monetary way, this is a great way to do it.
On iTunes or Stitcher or wherever you see our podcast, you could leave a nice comment. That'd
Thanks
be
so
awesome.
much. Yeah, thank you.
Thank you, Vinny.
Thank you, Katie.
Thank you, Frederick.
Thank you, Frederick.
Thank you for listening.
Thank you, listeners.
See you next time.
Bye-bye.
Bye.